Over the last 24 to 48 hours, a series of photographs has started to move through the quiet, private corners of the internet, specifically through astronomy forums where people who know the night sky gather to share their work. These photographs should not exist. Not in the way they look, not with the details they claim to show. These are images that, if they are proven to be authentic, make every single official explanation about the interstellar object known as 3I Atlas fundamentally and completely insufficient. And here is the detail that is going to echo in your mind long after this is over. The major space agencies, including NASA, are not saying a single word about any of them. Let me be as direct and as clear as I possibly can with you. You are watching this at a very specific and unique moment in time. Right now, as you are listening to my voice, an object that was born in the darkness between the stars, a traveller from another solar system entirely, is passing through our own cosmic neighbourhood. It is, in astronomical terms, relatively close to us. It is visible through telescopes. It is being photographed by people all over the world. And the images that are coming back from those telescopes are creating a silent but deeply felt crisis within the communities that study these things, a crisis that the mainstream media has, for reasons we must explore, completely and utterly ignored. How is that even possible in our modern connected world? How can something this immediate, this significant, this directly observable, remain buried in the technical discussions of online forums and private channels? Your evening news will talk about politics, about the economy, about sports, about everything under the sun, but it will not talk about this visitor from beyond it. I need you to grasp something essential before we proceed any further into this mystery. What we are discussing today is not a matter of speculation about distant possibilities or ancient events. This is not a conspiracy theory that is built upon an absence of evidence or a lack of information. What we're talking about is happening right now in the sky above your head. It is an event that is observable with the right equipment, an event that is being documented by a growing number of independent sources. The entire foundation of this investigation is built on data, on observations that are creating a direct conflict with the official, simplified narratives we have been given. The photographs we are going to examine, these so-called leaked images that began to surface online only a few days ago, are not grainy artifacts from decades past. They are current, they are recent, and they are raising profound questions that the official channels seem deeply, profoundly uncomfortable with addressing. Here is what makes this situation so extraordinary, so different from the usual online chatter. When these images first started to appear on platforms like Reddit, on X through a series of X posts, and on highly specialized astronomy forums, the response from the community was not what you might expect. In these private Discord channels, which are frequented by a mix of dedicated amateur astronomers and professional researchers, the reaction was not one of immediate dismissal. It was a debate, a serious, technically detailed and rigorous debate about what these photographs were actually showing to the trained eye. And then, almost as quickly as the debate began, a strange kind of quiet started to descend upon these conversations. It was not the silence that follows a successful debunking, where a clear explanation puts all questions to rest. It was the silence of deep uncertainty. It was the kind of quiet that falls over a room when people who truly know what they are looking at, who have spent their lives studying these phenomena, see something that simply does not fit into any of their existing frameworks, any of their established models. This is the sound of cognitive dissonance on a community-wide scale. To understand why these photographs are having such an impact, you need to know that everything about 3I Atlas has been unusual from the very beginning. The way it was first detected, the series of observations that followed, the strange and documented colour changes recorded by multiple observatories, the unexpected fluctuations in its brightness that confuse scientists who are on the record with their puzzlement, the specific signatures of water that were detected in a way that raised more questions than answers. All of this is verified, it is documented, and it has been published in the scientific literature. None of that is in dispute. What is in dispute is what it all means. And now, these photographs have entered into that already complicated context. These are images that were allegedly captured during the most recent observation windows, and they are circulating with specific claims about visible structural features, about characteristics on the object's surface, about fine details that simply should not be visible on what we are being told is just a fragmenting comet, an object that should be completely shrouded in a thick cloud of its own dust and gas. This is a direct contradiction of the official story. Online communities are now engaged in a feverish grassroots analysis. People are examining the pixel data of these images, looking for signs of manipulation or processing artifacts. They are comparing these new, unverified images with the older, verified photographs that were taken by established observatories months ago. And the conversations that are happening in these dedicated spaces are not the fringe conspiracy discussions you might imagine. They are technical analyses involving people who have a deep understanding of orbital mechanics, of spectral analysis, of advanced photographic enhancement techniques, and of cometary physics. Here is the thing, and this is precisely why I need you to hit that like button right now before you forget, because this truly matters. These images are being circulated and discussed in the very same online spaces where actual credentialed scientists participate. They are being analysed by people with advanced degrees, with access to professional-grade equipment, with scientific reputations to protect. And yet, when you turn on your television, when you browse the major news websites, you find complete and total silence. CNN is not covering this story. The BBC is not investigating these claims. The major science publications, the very institutions that should be at the forefront of either confirming these images or definitively debunking them, are not touching this subject. That silence, in and of itself, is a powerful form of information. When something is obviously and demonstrably fake, the process of debunking it is swift, public, and definitive. When something is complicated, when something has the potential to challenge accepted narratives, when something requires a deep investigation that might lead to uncomfortable or paradigm-shifting questions, that is precisely when you get this kind of profound institutional silence. If you're the type of person who wants to see what they are not showing you, what they seem to be actively and deliberately avoiding, then you need to stick around. I want you to drop a comment right now telling me where in the world you are watching from, because I want to know if you are seeing these same observations, if you are feeling this same sense of unanswered curiosity. Because in the next hour, we're going to examine something that challenges everything that official sources have told us about this interstellar visitor. We're going to look at the documented anomalies that preceded the appearance of these photographs. We're going to examine what credible scientists have already said, on the record, about observations that do not fit the standard models of cometary behaviour. And then, only after we have built that solid foundation of fact, will we get to the photographs themselves. We will look at the specific claims being made about them, and we will explore why the complete lack of response from official channels is, in itself, one of the most revealing parts of this entire unfolding story. Tell me something. When was the last time you encountered a piece of information that genuinely, truly surprised you? I do not mean surprised in the way a movie plot twist surprises you. I mean intellectually challenged in a way that made you stop and question something you thought you fundamentally understood about the world, about the universe. That is exactly what is happening in astronomy circles right now, in this very moment. People who study comets for a living, who understand the intricate physics of these celestial bodies, who know exactly what should happen when an interstellar object passes through our solar system, they are seeing things that do not align with their predictions, and some of those things are allegedly captured in these leaked photographs. I want to be completely transparent with you about what we are doing here. This is not a video that is going to claim to have all the definitive answers. This is an investigation into the questions that are not being asked publicly, the questions that seem to be too uncomfortable for the mainstream to touch. We are going to examine what is being claimed, we are going to look at the evidence that either supports or contradicts those claims, and we're going to try to understand why the larger scientific establishment seems so profoundly reluctant to engage with any of it in a public forum. You're going to see the data for yourself. You're going to hear what credible researchers have said on the record, and you're going to encounter the photographs that are causing this quiet but intense confusion in communities that deal with this subject matter professionally every single day. One more critical piece of information before we dive deep into the evidence. November of 2025 is the prime observation window. It is happening right now, this month. The object 3I Atlas becomes visible again in the pre-dawn sky on November 11th. Its closest approach to our planet, Earth, happens on December 19th. This is the climax of its journey through our system. If you have access to a telescope with a decent aperture, a decent-sized mirror or lens, you can observe this object for yourself. You can take your own photographs. You can directly compare what you capture with your own equipment to what is being discussed and debated online. This is not ancient history that we are arguing about. This is a present-tense, observable reality. And that is precisely what makes the silence from official sources so conspicuous, so deafening. When something's happening now, when it is visible now, when it is documentable now, and the major media outlets are not touching it, you have to stop and ask yourself a very simple question. Why? What is it about this specific topic that makes it so radioactive? What makes these particular questions so dangerous to ask? What is it about these photographs, these observations, these technical discussions happening in specialized communities that has created this complete vacuum of mainstream coverage? That is what we are here to explore, not to give you answers that are wrapped in a false sense of certainty, but to examine the questions that are wrapped in a very real and credible uncertainty. So, let's begin where this story takes its most fascinating turn, not at the discovery of 3i Atlas itself, because you probably already know that part of the story, but at the series of observations that followed. We will look at the anomalies that slowly but surely accumulated, and the pattern of official responses that set the stage for why these leaked photographs matter at all. You already know that 3i Atlas did not originate in our solar system. You probably know that it was detected earlier this year, that it is only the third confirmed interstellar object that we have ever identified. You likely know that it is currently making its way through our cosmic neighbourhood on a trajectory that brings it closer to Earth than any previous interstellar visitor we have ever had the chance to study. That is the basic headline version of the story. But what you might not know, what does not make it into those brief, superficial summaries, is that from the very beginning, from those first moments of detection, something was just a little bit off. It was not dramatically off, not obviously wrong in a way that would grab headlines. It was just inconsistent. There were small details that did not quite match our expectations, observations that required explanations that were slightly more complicated than they should have been. It was the kind of subtle discrepancy that scientists notice, discuss among themselves in technical papers, and then typically move past by amending their predictive models. Except this time, the discrepancies just kept accumulating. Each new observation, each new data point, added another small question mark to the file. Each attempt to explain one particular anomaly seemed to inadvertently reveal another one, creating a cascade of puzzlement. Let me give you some context for why this matters so much. When you detect an interstellar object, you're working with predictions that are based on sophisticated models we have developed from observing thousands upon thousands of comets and asteroids that are native to our own solar system. We have a very good idea of what comets do. We understand their behavior patterns with a high degree of confidence. We can predict how they will brighten as they get closer to the sun, how they will develop their characteristic tails, and what their spectral signatures should reveal about their chemical composition. These are not wild guesses. They are robust scientific frameworks that are built upon decades of careful observation and a mountain of collected data. So, when an object behaves differently than those frameworks predict, it is noteworthy. It is something that makes scientists pay closer attention. When multiple observations, taken by different teams using different instruments, all show unexpected characteristics, it becomes genuinely puzzling. And when those puzzles persist across different observatories, across different detection methods, it evolves into a legitimate and profound scientific question. The object 3i Atlas accumulated those puzzles faster than our explanations could comfortably account for them. The very early observations of the object showed colour characteristics that did not quite match the standard models for cometary composition. They were not wildly different, just enough to require some adjusted explanations and new assumptions. Then came the measurements of its brightness, which were observed to fluctuate in ways that suggested either a highly unusual rotation pattern or something strange about the object's surface properties that did not fit the typical profile of a comet. Again, these fluctuations were explainable, but only with certain modifications to our standard assumptions, and the need to make those modifications in the first place was a red flag. Here is where the story starts to get really interesting. By the late summer of 2025, a number of different observatories were tracking 3i Atlas as it made its approach towards perihelion, which is its closest point to the Sun. This is the period when comets typically become their most active and spectacular. the intense solar radiation heats the surface, causing the ice to sublimate directly into gas, which in turn creates the brilliant glowing tails that we associate with cometary displays. We had very specific predictions for how bright 3I Atlas should become, predictions that were based on its estimated size, its estimated composition, and its precise orbital trajectory. Those predictions were based on solid physics, and they turned out to be wrong. On October 31st, just a few days ago, 3I Atlas exhibited an unexpected brightening event that simply was not supposed to happen. It was not a dramatic, explosive brightening, but it was a clearly measurable increase in its luminosity that did not correspond with where it was in its orbit or what level of solar radiation intensity it was experiencing at that moment. Scientists who were on the record described this event as confusing. That is a very careful and deliberate word. In the language of scientific literature, the word confusing means that we do not have a comfortable, straightforward explanation that fits neatly into our existing models. It is a polite way of saying that something is happening that we do not fully understand. But this brightness anomaly was not an isolated incident. Around the same time, observations that were being made from the Neil Gerald Swift Observatory, a space-based telescope, detected what are known as hydroxyl gas signatures. These signatures are essentially the chemical fingerprint of water molecules being broken apart by solar radiation. Now, finding the signature of water around a comet is not shocking in itself. Comets are known to contain a great deal of ice. That ice sublimates when it gets near the sun, and water vapor appears. This is a routine observation, except the amount and the distribution pattern of these hydroxyl signatures did not quite match what the object's size and its distance from the sun should have produced according to our models. There was more of it than we expected, and it was present in ways that suggested that either the object contained more volatile materials than our initial composition estimates had indicated, or that something about how those materials were being released from the surface was not following the standard, predictable patterns of sublimation. It was another piece of the puzzle that did not quite fit. Then came the colour changes, and these are not a matter of speculation. These are documented, measured colour changes. By early November, observers noted that 3I Atlas had developed a faint but distinct bluish hue that had not been present in any of the earlier observations. This marked the third distinct colour shift that had been recorded since the object was first detected. Each of these changes corresponded loosely with the different phases of its approach and its passage around the sun, but the specific sequence and the characteristics of these colour transitions did not precisely match any known pattern of cometary behaviour. They were close, similar enough that they could be explained away as a form of natural variation, but they were also distinct enough that the scientific papers examining the object kept noting these characteristics as being unusual. Do you see the pattern that is forming here? No single observation, when taken in isolation, is completely inexplicable. Each individual anomaly has a possible, albeit sometimes creative, natural explanation. But it is the accumulation of these anomalies, the consistent and persistent pattern of observations that require special explanations, of data points that sit just outside the predicted parameters, that creates what I call a documented mystery. This is not a conspiracy. This is not wild, unfounded speculation. This is the scientific record itself showing us an object that persistently, and in multiple ways, refuses to behave exactly as our models predict that it should. And here is what makes this context absolutely crucial for understanding the significance of the leaked photographs. By the time these images started to circulate in early November, the astronomical community was already in a state of heightened attention regarding 3I Atlas. This was not just some random object that was receiving routine observation. This was an interstellar visitor that was actively exhibiting a range of unusual characteristics that multiple professional observatories had already documented. Credible, respected scientists were already discussing the object's atypical behaviour in published research papers and at scientific conference presentations. The question was not whether 3I Atlas was behaving normally. It was clear to everyone involved that it was not, at least not by our strict established standards. The real question was whether its unusual characteristics represented a form of natural variation within the broad spectrum of cometary behaviour, or if they were pointing towards something more fundamentally different, something outside of our current understanding. That was the atmosphere into which these photographs emerged. They did not appear in a vacuum of ignorance, but rather into an ongoing scientific discussion about an object that was already raising a series of legitimate and unanswered questions, and that context matters enormously for how we evaluate both the images themselves and the deafening response, or non-response, from the official sources. There is something else you need to understand about the specific timeline here. Early November of 2025 marks the period when 3I Atlas became optically observable again after its passage around the Sun, its perihelion. For several weeks prior to this, it had been too close to the Sun's position in our sky for any effective observation from Earth. The overwhelming brightness of our own star made it impossible to capture any detailed images. But as the object moved away from that alignment, new observation windows began to open up. This is precisely when multiple observatories, both the large professional institutions and the smaller amateur setups, began to capture new images of the object in its post-perihelion state. And this is exactly when the leaked photographs allegedly originated. They are images that were supposedly captured during these early November observation sessions, processed through standard astronomical imaging techniques, and then shared in the online communities where people analyze this kind of data. The claims that are emerging around these images did not appear in isolation. They appeared in the context of months of documented anomalies, in the wake of scientific papers that were already noting its unusual characteristics, and into an astronomical community that was already deeply puzzled by what they were observing. So when we talk about these leaked photos, we're not talking about images that suddenly appeared from nowhere, making wild and unsupported claims about an otherwise normal object. We're talking about photographs that entered into circulation during a period when the object's behavior was already well documented as being atypical, when scientific interest was already elevated to a high level. This was a time when the observation conditions had just improved enough to allow for the capture of highly detailed imagery. That context completely transforms how we must evaluate both the images themselves and the response, or the conspicuous lack of a response from the official sources. Let me show you something that most of the minimal coverage of this event completely glosses over. If you pull up any mainstream article about 3I Atlas, you will get the basic sanitized narrative. An interstellar comet is passing through our solar system, and scientists are observing it. It is interesting, but it is presented as being routine. What you will not get is the actual observational data that makes this object genuinely anomalous. It is not anomalous in a sensational way that screams for headlines, but it is anomalous in a persistent, documented, and scientifically acknowledged way that raises a series of profound questions that no one in an official capacity seems eager to answer publicly. Let's start with those colour changes that I mentioned earlier. This is not a matter of subjective interpretation. Multiple observatories recorded the spectral data, which is a way of measuring the light from an object to determine its composition, and this data showed distinct shifts in the object's colour profile over time. The very first shift occurred during its initial approach to our inner solar system, when the object transitioned from a relatively neutral, grey colour to a distinctly reddish hue. This corresponds with what we would expect to see from a carbon-rich surface that is being exposed to intense solar radiation for the first time. This is standard, predictable cometary behaviour. But then, as it continued its journey towards its closest approach to the Sun, the colour shifted again. This time, it moved towards a more neutral, almost greyish appearance. That is highly unusual. Comets typically get redder, not greyer, as the organic compounds on their surface are processed and altered by solar radiation. The third shift, that faint bluish hue that developed in early November after it had passed the Sun, is where the explanations from scientists start to get very creative. A blue colouring in comets typically indicates the presence of specific chemical compositions or certain sizes of dust grains that scatter light in particular ways. But for that blue tint to appear after the perihelion passage, after the object had already been subjected to the most intense solar radiation of its journey, and after two previous and distinct colour shifts had already occurred, that specific sequence does not fit cleanly into any standard model of cometary evolution. It is, in theory, explicable, but it requires us to assume very specific compositional characteristics and very particular surface processes that we have no independent confirmation of. In essence, we are being forced to make the explanation fit the observation, rather than having the observation confirm our existing predictions. Now let's layer the object's brightness behaviour on top of that already confusing picture. The unexpected brightening that occurred on October 31st was not an isolated incident. It was simply the most dramatic event in a longer series of brightness fluctuations that had been puzzling observers for weeks. Comets brighten and dim based largely on two factors: their distance from the Sun and their level of activity, which means how much material is sublimating off of their surface. You can predict these brightness curves with a reasonable degree of accuracy if you have a good estimate of the comet's size and composition. But 3i Atlas kept deviating from those predictions. Sometimes it was brighter than it was expected to be, and at other times it was dimmer, following a pattern that suggested that either the object was rotating in a highly unusual manner, exposing surfaces with dramatically different reflective properties, or that its level of activity was fluctuating in ways that simply do not match our standard models of cometary outgassing. Some scientists tried to account for this by proposing that the object might be fragmenting, that large chunks of it were breaking off, which would temporarily increase its brightness as fresh, unexposed surface material was revealed to the Sun. Fragmentation is a common occurrence for comets that are under intense solar stress. It is a perfectly reasonable explanation, except the observations that were specifically looking for the evidence of fragmentation, for debris fields, for secondary objects, for the expanding dust clouds that are characteristic of these breakup events, did not find any clear confirmation. The object appeared to remain relatively intact. So you had a situation where the brightness behavior was suggesting that fragmentation was occurring, but the direct imagery was suggesting that the object was maintaining its cohesion. This was another puzzle that required another creative and unproven explanation. Then there is that water signature data from the Neil Gerald Swift Observatory. On November 2nd, the observatory detected what are known as hydroxyl emissions, which indicated that water was present and was being released from the object. But here is the specific detail that truly matters. The amount and the distribution pattern of this water suggested that it was not coming uniformly from the entire surface, as you would expect from the standard process of ice sublimation. The emission pattern was more concentrated, almost directional in nature. Some observers noted that this could indicate that the water was being released from specific active areas on the surface, rather than from a general sublimation process across the entire object. This does happen with comets. Sometimes they develop active jets that spew material from particular locations, but the pattern of the hydroxyl emission from 3i Atlas was more pronounced than what we typically see from jet behavior. It looked almost as if the water was being actively expelled from specific points, rather than passively sublimating from the surface ice. I want to pause here for a moment and emphasize something absolutely crucial. Every single detail that I have just described to you is documented in the official scientific observation records. These are not rumors. These are not fragments of online speculation. These are the published findings from credible professional observatories that were using standard, accepted detection methods. There are scientists on the record who have noted these characteristics and have expressed their puzzlement about them. The mainstream scientific establishment is not denying that any of this is happening. They are just not emphasizing it. It gets mentioned in the fine print of technical papers, it gets discussed at specialized conferences, it is noted in the appendices of observation reports, but it does not make its way into the public science communication. NASA's public updates about 3i Atlas present it as a straightforward, interesting interstellar comet. The complications, the anomalies, the unexplained characteristics, those tend to stay buried in the dense technical literature that general audiences never encounter. Here is another observation that barely received any attention at all. The European Space Agency's instruments tracked 3i Atlas during its close approach to the planet Mars in September. Mars does not have Earth's thick atmosphere to interfere with observations, and the ESA instruments had a unique viewing angle during that particular time frame. They captured spectral data that showed significant inconsistencies. The compositional signatures that they detected were not matching the initial estimates that had been made from earlier observations. Certain elements that should have been present were not showing strong signatures, while other elements that should not have been prominent were. The official explanation that was provided was that the object's composition was more heterogeneous than had been initially thought, meaning that different areas of the object had different chemical makeups. Again, this is a reasonable explanation, but it is also, again, an explanation that was created specifically to fit an unexpected observation, rather than an observation that confirmed an existing prediction. Some Japanese amateur observers noted that in late October, 3i Atlas exhibited what they described as irregular coma development. The coma, which is the cloud of gas and dust that surrounds a comet's solid nucleus, typically develops in very predictable patterns as the comet heats up. But 3I Atlas developed a coma that seemed to expand and contract in ways that did not correlate cleanly with its distance from the Sun or its predicted levels of activity. Some days it appeared to be more active than it should have been, while on other days it was less active. The pattern did not seem to match the intensity of the solar radiation or any other obvious trigger. It was, for lack of a better word, simply irregular. One more detail that is going to become extremely important when we begin to discuss the leaked photographs. In late September, the Gemini South telescope in Chile captured what are still considered to be some of the best, most clearly verified images of 3I Atlas. These images showed clear coma and tail development. They documented the object's visual characteristics at a very high resolution, and they provided a crucial baseline for what the object looked like during that specific observation window. These are the images that scientists officially reference when they are discussing the object's appearance. They are clear, they are verified, they have been published, and they are accepted by the scientific community. When we get to the leaked photographs from November, I want you to keep these September images firmly in your mind, because the comparison between the verified September imagery and the alleged November imagery is where this story gets genuinely strange. Notice what I am doing here. I am not leading with the most sensational claims. I am carefully building a foundation of documented scientific observation that firmly establishes that this object has been consistently unusual across multiple independent detection methods, across multiple observatories, and across multiple observation windows. This is not about any single, shocking revelation. It is about a persistent pattern of data that refuses to align perfectly with our predictive models. Each individual anomaly, taken on its own, is small. But these small anomalies accumulate, and that accumulation creates a legitimate scientific mystery. And that accumulation is precisely what makes the leaked photographs so significant. They did not appear in a vacuum, making wild claims about an otherwise normal object. They appeared in the context of months of documented unusual behaviour into a scientific community that was already puzzled by observations that required creative explanations, and they did it during a crucial observation window when new, highly detailed imagery was just becoming possible. The photographs are just one more data point in a much larger pattern of this object not quite behaving as we expect it to. Whether they are authentic, whether the claims being made about them are accurate, whether they truly reveal what some observers say they reveal, that is what we need to examine next. So, here is where the story shifts from the realm of documented scientific anomalies to something far more contentious, far more uncertain, and significantly more controversial. Starting around November 3rd, 2025, just a couple of days ago, a series of images began to appear in online astronomy communities, all of them claiming to show highly detailed views of 3I Atlas that were captured during the most recent observation windows. These were not official NASA releases, and they were not from peer-reviewed scientific publications. They were photographs that were circulating through the astronomy forums on Reddit, through Discord servers where amateur astronomers share their observations, and through specialized image-sharing platforms that are used by people who process astrophotography data. The first thing you need to understand is how these images allegedly originated. According to the posts that accompanied them, they were captured by multiple independent observers who were using a variety of different telescopes during the early November observation sessions, right when 3I Atlas became visible again after its passage around the Sun. Some of the posts claimed to be from amateur astronomers who owned very serious equipment. We are talking about telescopes with apertures ranging from 10 inches to 16 inches, paired with professional-grade cameras and sophisticated imaging software. Other posts claimed that the images came from smaller independent observatory networks that share their data publicly, but do not necessarily get the attention of the mainstream media. A few of the posts even suggested that the images were actually processed versions of raw data from much larger, unnamed observatories that someone had gained access to, and then enhanced to bring out the hidden details. Now, immediately, we find ourselves in very uncertain territory. These are not images that come with clear, verified chains of custody. They are not published with the full metadata that would show exactly when, where, and how they were captured. They are, for all intents and purposes, anonymous contributions to online discussions, uploaded by users with varying levels of credibility, and they are accompanied by claims that may or may not be accurate. This is an important piece of context. I am not presenting these to you as verified NASA photographs that have been leaked from official classified channels. I am telling you that images which claim to show very specific details about 3i Atlas are currently circulating in the communities where people analyze astronomical data, and that those images are generating a significant amount of discussion and very serious debate. What do these images allegedly show? This is where it gets very specific, and where I need to be extremely careful about how I frame this information. Multiple versions of these images now exist, and they have been processed in different ways by different people, but the consistent claims that are being made across the various posts tend to focus on a few key observations. First, the claim is that when the images are properly processed and enhanced, using standard techniques in astrophotography to bring out fine detail, they appear to show a surface structure that is unusually distinct for an object at the distance of 3i Atlas. We are talking about an object that is over 268.9 million kilometers away from us. At that immense distance, even with very good telescopes, you would typically expect to get a fuzzy blob, perhaps with some visible detail in the surrounding coma, but certainly not clear features on the surface of the object itself. These images, as they have been posted, appear to show subtle geometric patterns. This is not dramatic. It is not like looking at a photograph of a spacecraft with obvious engineered features. It is much more subtle than that. But observers are claiming that certain areas of the object show regular patterns, edges that seem to be too straight, and symmetries that seem highly unlikely for a natural fragmented rock that is covered in sublimating ice and dust. The specific claim is not "this looks like a machine." The specific claim is that this shows structural features that are very difficult to explain as the result of random fragmentation or natural geological processes. The second major claim involves what is being described as unusual dust coverage patterns. When you look at an active comet, you are seeing it through a thick haze of dust and gas that it is actively releasing into space. That haze should, by all rights, obscure the surface details, create a fuzzy and indistinct appearance, and make it impossible to see any clear structure that might lie underneath. But these images allegedly show areas where the dust coverage appears to be uneven, spots where the surface detail is more visible, as if whatever is underneath is either not releasing material uniformly, or is somehow visible through the coma in ways that should not be possible given our understanding of standard cometary physics. Third, there are claims being made about a consistency in the brightness of certain features across several of the circulating images. Observers have noted that certain specific features appear to maintain a consistent level of brightness relative to each other across different images that were captured at different times. If you are looking at a tumbling, fragmenting, outgassing comet, you would fully expect the brightness patterns to shift constantly as different surfaces rotate into view, as the distribution of the surrounding dust changes, and as the levels of activity fluctuate. But the claim here is that specific features that are visible in these images maintain a similar relative brightness and position, which would suggest either a very slow rotation, a remarkable degree of structural stability, or surface characteristics that remain consistent despite the object's ongoing exposure to intense solar radiation. Now, here is where we enter the territory of serious evaluation. How do we assess these extraordinary claims? First, we have to look at the discussion that is happening around the images themselves. When something is obviously fake in the world of astronomical photography, experienced observers can identify it very quickly. They analyze the pixel data, they check for the telltale artifacts that are left behind by digital processing, and they compare the image with known imagery that was taken from the same time period using verified equipment. The conversation that is happening around these 3i Atlas images is not one of immediate dismissal, it is a debate. Some observers are arguing that the features are nothing more than artifacts of the image processing itself, that when you enhance astronomical images to bring out faint details, you can inadvertently create the appearance of structure that is not really there. This is a well-known phenomenon called pareidolia. Others are arguing that they have processed similar datasets independently, and are seeing very similar features. Some are claiming that they have observed 3i Atlas themselves with comparable equipment, and that their images do not show any of these features. Others are saying that their images do show unusual characteristics, but that they are not sure how to properly interpret them. In the 24 to 36 hours since these images began to circulate, roughly on November 4th and 5th, Some reports that were circulating in Japanese astronomy communities noted that recent imaging of 3i Atlas showed what they described as unexpected visual characteristics that did not match the previous observation data from September. They specifically mentioned that the object's appearance had changed in ways that were not fully explained by the predictable changes in viewing angle, distance, or activity level. They did not post the same dramatic images that were circulating on Reddit, but they did acknowledge that they were seeing something unexpected that required further investigation. This is what makes the situation so incredibly complicated. You have unofficial images that are making very specific claims, and these are circulating online. You have official observation organizations that are noting unexpected characteristics without providing any detailed imagery to the public. You have some amateur astronomers saying that they see unusual features, and you have other amateur astronomers saying that they do not. You have image processing experts who are debating whether the details in the enhanced images are real or if they are just artifacts. And through all of this, you have complete and total silence from the major institutional players, from NASA, from the ESA, and from the major observatories about any of this discussion. That silence is perhaps the most fascinating and revealing element of this entire situation. When clearly fake astronomical images circulate online, these institutions typically respond very quickly with official debunking statements. When something legitimate but misunderstood is circulating, they will often clarify the situation with educational posts. When the images that are circulating are genuine but are being misinterpreted, they will provide the necessary context. But here, with these 3i Atlas images generating substantial and serious discussion in the astronomy communities, some of which include professional researchers, there has been no response at all, no confirmation, no debunking, no clarification, just a complete absence of information. Let me be absolutely clear about what I am presenting here. These are unverified images that are making specific claims, circulating in online communities, and generating a debate among people with varying levels of expertise. I am not telling you that these are authentic NASA photographs that have been leaked from classified channels. I am not telling you that these images definitively show what some observers claim that they show. What I am telling you is that during a crucial observation window for an object that has already exhibited a long list of documented anomalies, images are circulating that are generating a serious technical discussion. And the institutional response to that discussion has been complete and total silence. The story, then, is not necessarily about the images themselves. The story is about the pattern. You have an unusual object exhibiting behavior that has been documented by official sources. You have an observation, window opening that allows for highly detailed imaging. You have images appearing that claim to show unexpected features. You have a technical community that is seriously debating those images, and you have the official sources completely ignoring the entire discussion. Do you see now why the context matters so much? If these images had appeared 6 months ago, making wild claims about 3i Atlas when the official observations were showing completely normal behavior, the entire discussion would be different. But they appeared after months of documented anomalies, during a window when new, detailed observations were just becoming possible, and they appeared into a community that was already actively discussing the object's unusual characteristics. They are not creating a mystery out of thin air, they are adding a new and perplexing layer to a mystery that already exists. And that existing mystery, that solid foundation of documented scientific puzzlement, is what we need to examine more closely. Because whether these specific images are authentic or not, whether the features that observers claim to see are real or just artifacts, the underlying question remains the same. Why has this object consistently behaved in ways that require special explanation? Why has every single observation session revealed characteristics that do not quite match our predictions? And why, when images that are circulating online claim to show structural anomalies, is the response from the official channels not clarification, but silence? That is the fundamental question that sits at the very heart of this quiet crisis, and to answer it, we must now move from documenting the evidence to exploring the possible explanations. We have to build a spectrum of possibilities, ranging from the most conservative and scientifically orthodox all the way to the most radical and paradigm-shifting. Because when you are faced with a pattern of anomalies this persistent, you have to be willing to consider every single possibility, no matter how uncomfortable it might be. Let's begin with the explanation that any mainstream scientist would offer you first, the one that requires the fewest new assumptions. This is the conservative view, the baseline against which all other explanations must be measured. In this view, every single unusual characteristic of 3i Atlas is, ultimately, the result of natural but unfamiliar cometary processes. The argument is simple, and on the surface, very compelling. This object is not from our solar system. It was born in a completely different stellar environment. It was formed from a different protoplanetary disk. It has orbited a different star for billions of years, and it has travelled through the interstellar medium for an unknown length of time before arriving here. Therefore, we should not be surprised that it behaves differently from the comets we are familiar with. Our models, which are based exclusively on comets native to our own solar system, are simply incomplete. This explanation has the virtue of being scientifically responsible. It adheres to the principle of Occam's razor, which states that the simplest explanation is usually the best one. It is far simpler to assume that our understanding of comets is incomplete than it is to assume that we are looking at something fundamentally different. Perhaps the star system where 3i Atlas was born was richer in certain types of volatile gases, which would explain the unusual hydroxyl signatures. Perhaps the dust grains in its native protoplanetary disk were of a different size or composition, which would account for the strange sequence of colour changes. Perhaps the object itself has a bizarre shape, or an unusual internal structure that was created by the specific gravitational dynamics of its home system, which could explain the brightness fluctuations and the irregular coma development. This is a perfectly reasonable and intellectually sound position to take, but it also has a significant weakness, and that weakness grows with every new anomaly that is documented. The problem is that this explanation requires us to accept a very high number of independent, coincidental, unusual characteristics in a single object. It is one thing for an interstellar comet to have an unusual colour. It is another for it to also have an unusual brightness pattern. It is yet another for it to also have an unusual water signature. And it is something else entirely for it to also have an unusual coma development pattern. At what point does the accumulation of these independent anomalies become so statistically improbable that the "it's just a weird natural comet" explanation starts to feel less like a simple explanation and more like a strained attempt to fit a square peg into a round hole? Imagine you found a car on the side of the road. If it had square wheels, you might say, well, that's unusual, but perhaps it's some kind of experimental art car. If it also ran on salt water instead of gasoline, you might say, that's also very unusual, but maybe it's a new type of fuel cell technology. If you then discovered that its body was made not of metal, but of carved solid oak, you would have to start questioning your initial assumptions. Each of these features, taken in isolation, has a possible, albeit strange, explanation. But all of them existing together in a single object strongly suggests that you are not looking at a normal car with a few unusual features. It suggests you are looking at something that belongs to a completely different category of object altogether. That is the logical problem that the conservative, natural explanation for 3i Atlas is beginning to face. It requires us to accept too many coincidences at once. This leads us to our second major possibility, the compositional hypothesis. What if 3i Atlas is not really a comet at all? What if it is primarily a rocky object, an interstellar asteroid, that is simply masquerading as a comet? This idea has a great deal of explanatory power. A solid, rocky body would have a much higher degree of structural integrity than a loosely packed dirty snowball of ice and dust. This could account for why it has not shown clear signs of fragmentation despite its close pass by the Sun. It could also explain the brightness stability that some observers have noted, as a solid, rotating object would have more consistent reflective properties than an outgassing comet with a constantly changing dust cloud. This hypothesis could even explain some of the cometary activity. It is possible that a rocky asteroid could have pockets of volatile materials, like water ice, trapped beneath its surface. As the object gets closer to the Sun, the surface heats up, and these subterranean pockets of ice could vaporize, building up immense pressure until they burst through the rocky crust in violent, localized jets. This would perfectly explain the observation of hydroxyl signatures that seem to be coming from specific, active points rather than from the entire surface. It would look like cometary activity, but it would be driven by a completely different physical mechanism. This is a very elegant explanation for many of the observed anomalies, but it too has some significant problems. First, the sheer amount of water that was detected by the Neil Gerald Swift Observatory seems to be too high to be explained by just a few isolated pockets of trapped ice. The volume of the hydroxyl cloud suggested a very significant release of water vapor, more in line with what you would expect from a true comet with a surface that is rich in ice. Second, and more importantly, this explanation does not do anything to account for the most perplexing claim of all, the alleged geometric regularity of the features seen in the leaked photographs. A fractured asteroid would certainly have sharp edges and flat planes, but it would not have the kind of large-scale repeating patterns or angular symmetries that some observers are claiming to see. The fracturing of rock is a chaotic random process. It does not produce geometric order. So, while the asteroid hypothesis solves some of the puzzles, it fails completely to address the most controversial one. This brings us to our third possibility, the fragment hypothesis. This idea suggests that 3I Atlas is not a primordial object that formed on its own, but is instead a fragment of a much larger parent body that was destroyed in some kind of cataclysmic event long ago in its home solar system. Perhaps it is a piece of a small planet, or a large moon that was shattered by a massive impact or torn apart by the gravitational forces of a gas giant. This hypothesis is very good at explaining the object's heterogeneous composition. If you shatter a differentiated body, one that has a distinct core, mantle, and crust, the resulting fragments will be a jumble of different materials. Some pieces will be from the iron-rich core, some will be from the rocky mantle, and some will be from the ice-rich crust. This could easily explain why different observations of 3I Atlas have yielded conflicting compositional data. It could be that one side of the object is primarily rocky mantle material, while the other side is primarily icy crust material. This would account for the strange colour changes, the irregular outgassing, and the conflicting spectral signatures. It is a very robust explanation for many of the chemical and physical anomalies. But, just like the asteroid hypothesis, it runs into a major problem when confronted with the alleged visual evidence. What kind of natural geological process, even inside a planet, creates large-scale geometric regularity? The interior structures of planetary bodies are formed by processes like crystallization, sedimentation, and pressure fracturing. These processes can create beautiful and complex patterns on a small scale, like the crystalline structures you see in a geode, but they do not produce kilometre-scale structures with straight edges, right angles, and repeating symmetries on the exterior of a celestial body. Nature, on the grand scale of planetary geology, prefers spheres, chaotic fractures, and flowing, organic shapes. The kind of rigid geometric order that is being hinted at in the online discussions is simply not a known product of natural planetary formation or destruction. And so, we arrive at the fourth and final explanation. This is the one that is the most difficult to discuss, the one that carries the most intellectual baggage, and the one that official science is institutionally programmed to avoid at all costs. This is the perspective that has been most famously championed by the Harvard astronomer Avi Loeb in his analysis of the first interstellar object, Oumuamua. It is the simple but profound question: what if the object is not entirely natural? Before we go any further down this path, I need to be absolutely clear about what this means. This is not a claim that 3I Atlas is an alien spaceship that is here to visit us. It is not a leap to a sensational conclusion based on a lack of evidence. It is a methodological argument, a position of last resort that is rooted in the principles of scientific honesty. The argument goes like this. When all conventional, natural explanations for a set of observed phenomena require you to make increasingly elaborate, strained, and unproven assumptions, scientific integrity demands that you at least begin to consider less conventional possibilities. When the probability of a natural explanation relies on accepting a long chain of highly unlikely coincidences, you must be willing to compare that vanishingly small probability with the probability of a non-natural explanation, however small you may believe that to be. To reflexively dismiss the possibility of non-natural origins without even considering it is not a sign of scientific rigor. It is a sign of a failure of imagination. It is an intellectual dogma, not an evidence-based position. Applying this logic to 3I Atlas, the argument would be as follows. If the geometric regularities seen in the photographs are real, and if the accumulation of other anomalies cannot be explained by any single, coherent natural model without requiring a series of special, ad hoc assumptions, then we are obligated by the principles of science to ask the question, we must consider the possibility that we are observing an artifact of a non-natural process. What could a non-natural process even mean in this context? It does not have to mean a functioning, crude starship. The possibilities are vast and humbling. It could be a derelict piece of technology from a civilization that has been extinct for millions of years. It could be an interstellar probe, similar to our own Voyager probes but far more advanced, that has simply run out of power and is now tumbling silently through the cosmos. It could be a fragment of a much larger artificial construction, like a piece of a solar sail, a habitat, or a megastructure. It could even be something so far beyond our own technological and conceptual frameworks that we can barely even recognize it for what it is. The key point here is not to jump to any of these specific conclusions. The key point is to acknowledge that if the data continues to defy our best natural explanations, then this category of explanation, the non-natural or artificial category, must remain on the table. It must be considered as a valid, albeit remote, possibility. This is not a claim of artificiality. It is an argument for open-minded, data-driven investigation. It is a plea to follow the evidence wherever it leads, even if it leads to a place that is profoundly uncomfortable and deeply challenging to our preconceived notions about the universe and our place within it. And perhaps, just perhaps, this offers us a potential explanation for the most puzzling piece of this entire story: the institutional silence. Imagine you are in a position of authority at a major space agency. You're seeing the same data that we have just discussed. You're aware of the documented anomalies. You see the unverified images circulating online, and you know that while they might be artifacts, they might also be showing something real. You understand the profound species-altering implications if this object turns out to be anything other than a natural rock. How would you handle that situation? Would you rush to the public with incomplete information, risking either a global panic or worldwide ridicule if you turn out to be wrong? Would you issue a definitive statement that you cannot yet support with conclusive evidence? Or would you do exactly what we are seeing right now? Would you remain silent? Would you continue to gather data quietly, behind the scenes, while you try to figure out what you are really looking at? Would you avoid engaging with the online speculation? Because to do so would be to give it a legitimacy that you're not yet prepared to grant it. The silence from this perspective is not necessarily a sign of a cover-up. It could be the sign of a profound and unprecedented uncertainty. It could be the sound of institutions grappling with a possibility so monumental that they simply do not know what to say. And this is where the story pivots from the realm of analysis and speculation to the realm of immediate and urgent action. Because this is not a historical mystery that we are debating. This is not an abstract philosophical question. This is a real object passing through our solar system right now. And the window of opportunity to gather the data that could definitively answer these questions is closing, and it is closing very, very fast. We are living in an extraordinary moment. The period from November to December of 2025 is the absolute prime observation window for 3i Atlas. This is the brief fleeting period when the object is close enough, bright enough, and positioned correctly in our sky for us to get our best possible look at it. After this period, it will recede back into the darkness of interstellar space, moving away from us at a speed that will quickly make it too faint and too distant for any detailed observation. It will be gone, and it will be gone forever. We have one chance to get this right. Let me give you the key dates, the deadlines that are ticking away as we speak. On November 11th, just a few days from now, 3i Atlas will reappear in the pre-dawn sky for observers in the northern hemisphere. It will be visible on the eastern horizon within the constellation of Leo. This marks the beginning of the final, crucial observation campaign. Then, on December 19th, it will make its closest approach to our own planet, Earth. On that date, it will pass us at a distance of approximately 60.3 million kilometers. In astronomical terms, that is incredibly close. It is about 0.4 astronomical units, or less than half the distance from the Earth to the Sun. This will be the moment of maximum opportunity, the point at which our telescopes will be able to achieve the highest possible resolution and capture the most detailed imagery. But after that, the opportunity will begin to fade with astonishing speed. Some astronomers have cited December 15th as the effective end of the high-quality observation window, because even though its closest approach is a few days later, its trajectory will begin to carry it into angles that are more difficult to observe from Earth. After mid-December, it will be receding from both the Earth and the Sun simultaneously. With every passing day, it will grow dimmer. With every passing week, it will shrink in our viewfinders. By early 2026, it will be little more than a faint, indistinct point of light, accessible only to the most powerful professional observatories, and soon after that, it will fade completely, lost once more to the vast, empty darkness between the stars. We have, at best, a 6-week window, a brief 45-day period to gather as much independent data as we possibly can before this interstellar visitor, with all of its documented anomalies and its unanswered questions, vanishes forever. This is not a story that can be put on hold. This is not a mystery that can be solved next year. The clock is ticking, and the evidence is flying away from us at over 100,000 kilometers per hour. This is what transforms this entire situation from a passive intellectual exercise into an urgent call for independent crowdsourced science. The claims that are being made about 3i Atlas, the questions that are being raised by the leaked photographs, all of it is directly verifiable by independent observers. We do not have to rely on the silence of the institutions. We do not have to wait for an official press release that may never come. We, the public, the community of dedicated amateur astronomers and curious skywatchers, have the power to create our own data set. We have the ability to build a body of evidence that is so robust, so comprehensive, and so widely distributed that it cannot be ignored. What does it take to participate in this process? The equipment required is not trivial, but it is well within the reach of any serious amateur astronomer. You need a telescope with at least an 8-inch or 200mm aperture. A 10-inch or larger instrument would be even better, as it would provide greater light-gathering capability and higher resolution. You need a solid equatorial mount that can accurately track a moving object across the sky for long periods. You need a camera that is capable of taking long exposures, something like a DSLR or a dedicated astronomy camera. And of course, you need clear, dark skies, away from the light pollution of major cities. If you have this equipment, you have the power to contribute to solving one of the most profound scientific mysteries of our time. What should you be looking for? First, simply observe the object's general appearance. Does it look like a standard, fuzzy comet, or does it have a more distinct, almost stellar appearance? Document its brightness and its color characteristics. Do they match the official predictions, or do you see any of the unusual hues that have been reported? Most importantly, observe it over multiple nights. This is absolutely critical. By capturing images on consecutive nights, you can begin to distinguish real, persistent features from transient atmospheric effects or artifacts created by your own image processing. If you see an unusual feature, does it remain in the same relative position as the object rotates? Does it persist from one night to the next? This is how you build a credible observation. This is the power of distributed observation. A single image from a single observer is just an anecdote. It can be easily dismissed as an artifact, a mistake, or a hoax. But hundreds of images, captured by hundreds of independent observers all over the world using different equipment and different processing techniques, all showing similar anomalous features. That is not an anecdote. That is a robust data set. That is a powerful and undeniable body of evidence. This is open source science in action. This is an opportunity to create a narrative that exists outside of institutional control. A story that is told not by press releases, but by the raw, unmediated data gathered by a global community of citizen scientists. We have a chance to build a comprehensive observational record for 3i Atlas that previous interstellar objects, like Oumuamua, never received. Oumuamua was detected only as it was already leaving our solar system. It was a faint, distant point of light, and our opportunity to study it in detail was incredibly brief. But 3i Atlas is different. We have known about its approach for months. We have this prime, 6-week window of close observation. We have the technology, distributed among thousands of dedicated amateurs, to monitor this object with a level of continuous coverage that even the major professional observatories, with their limited and highly scheduled telescope time, cannot match. So as we stand here, on the cusp of this final observation window, we are faced with a choice. We can either sit back and passively consume the information that the official channels choose to give us, whenever they choose to give it, or we can become active participants in the process of discovery. We can use our own tools, our own skills, and our own passion for the unknown to gather the evidence that will either confirm or deny the extraordinary claims that are being made. The answer to the mystery of 3i Atlas may not be waiting in a NASA laboratory or an ESA data archive. It may be waiting in the backyard of a dedicated amateur astronomer with a 12-inch telescope and the patience to capture the truth, one photon at a time. The window is open, but it is closing. The choice is ours. Let us bring all of these threads together and try to understand exactly where we stand at this precise moment. What do we actually know, and what remains shrouded in uncertainty? The knowns are solid, they are documented, and they are the foundation of this entire investigation. We know that 3i Atlas is an interstellar object that has exhibited a series of scientifically documented anomalies. These include unexpected color changes, unexplained brightness fluctuations, unusual water signatures, and irregular coma development. These are not matters of speculation, they are part of the scientific record. We know that a series of unverified, but technically detailed photographs are currently circulating in online astronomy communities. We know that these images are generating a serious technical debate among experienced observers about the possible existence of unusual structural features on the object. We know that the major scientific institutions and space agencies have maintained a complete and conspicuous silence on this entire matter. And most critically, we know that we are entering a brief and final 6-week observation window, after which the object will be lost to us forever. Those are the facts. The unknowns are what make this story so compelling and so urgent. We do not know if the leaked photographs are authentic. We do not know if the features they allegedly show are real, or simply artifacts of image processing. We do not know the ultimate cause of the documented anomalies. We do not know the reason for the profound institutional silence. And most importantly, we do not know what future observations gathered over the next few weeks are going to reveal. We are standing on the edge of a great unknown, armed with a handful of perplexing facts and a mountain of unanswered questions. It is essential to understand the stakes here. Why does this moment feel so extraordinary? It is because this is not a historical event that we are analysing from a safe distance. This is not a documentary about a past discovery. This is a real-time investigation. The story is unfolding right now, as you are watching this. The evidence is not locked away in an archive. It is streaming towards us from the depths of space, waiting to be collected. And that is what makes this moment so unique. It offers a chance to participate. Rarely in the history of science has the public, the community of ordinary citizens, had the opportunity to contribute meaningful, potentially paradigm-shifting data to a live scientific mystery of this magnitude. This is not just about one strange object passing through our solar system. This is about a fundamental question regarding our place in the universe. For all of our history, we have looked up at the stars and wondered, are we alone? That question has always been the domain of philosophers, of priests, and of science fiction writers. But in recent years, it has become a serious data-driven scientific question. We now know that planets are common, that the building blocks of life are widespread, and that the universe is far vaster and more ancient than we could have ever imagined. The Copernican principle, the idea that we are not in a special or privileged position in the cosmos, suggests that if life and intelligence arose here, it has likely arisen elsewhere as well. The discovery of a genuine artifact of another technological civilization, even if it is ancient, derelict, and lifeless, would be the single most profound discovery in human history. It would be the ultimate confirmation of the Copernican principle. It would fundamentally and irrevocably change our understanding of ourselves, our future, and our place in the grand cosmic narrative. It would be the moment that humanity as a whole realizes that we are not the only minds to have ever looked up at the stars in wonder. I am not saying that 3i Atlas is that artifact, but I am saying that the possibility, however, remote, is what makes the stakes of this investigation so incredibly high, and it is what makes the silence from our institutions and the closing of the observation windows so agonizingly poignant. And so, we arrive at the end of our investigation, but at the very beginning of the most crucial phase of this entire story. What happens next is not up to me. It is up to you. I'm going to leave you with 3 very specific and very important calls to action. First, I need you to engage with this video. Hit the like button. More importantly, drop a comment below. Tell me where you're watching from. Share your thoughts, your theories, your questions. Share what kind of equipment you might have. This is not about vanity metrics. It is about the algorithm. Your engagement is what tells the platform that this story matters, that this is a conversation worth having. It is what prevents this story from being buried, from being silenced, from being ignored. Just as it is being ignored by the mainstream media, your engagement increases the visibility of this quiet crisis. Second, if this investigation has captured your curiosity, if you feel the weight of these unanswered questions, then subscribe to this channel and turn on your notifications. Over the next 6 weeks, as this final observation window plays out, I will be following this story relentlessly. I will be gathering the independent observations, I will be monitoring the discussions in the astronomy communities, and I will be bringing you updates as new, crowdsourced data comes in through November and December. This story is not over, it is just beginning, and you will want to be here as it unfolds. But the third and by far the most important call to action is this: look up. If you have the equipment, if you have a telescope and a camera, I am not just asking you to watch this story, I am asking you to be a part of it. Get out there, in the pre-dawn hours, and observe 3i Atlas for yourself. Document your methodology with meticulous care. Record the time, the date, the location, the equipment you used, the processing steps you took, and then share your findings, share your processed images, but more importantly, share your raw data. Upload it to the astronomy forums, let other people analyze it, be a part of the evidence-gathering process that can definitively answer these questions one way or another. Be the data point that helps to solve this mystery. In the end, we're all faced with a fundamental choice. We can choose to be passive consumers of information, waiting for the authorities to tell us what to think, waiting for the officially sanctioned narrative to be handed down to us. Or we can choose to be active participants in the search for truth. We can choose to believe in the power of independent observation, of citizen science, and of a community united by a shared sense of wonder and a relentless curiosity. The object known as 3i Atlas is now passing through our home. It is offering us a brief fleeting glimpse into the vast unknown universe from which it came. The window to see it for ourselves, to ask our own questions, and to find our own answers is closing forever. What we do in these next few weeks will determine whether we rise to meet this extraordinary moment or whether we let it slip away, unanswered, into the silent, star-filled darkness. The choice is ours. That choice, let's be clear, is more profound than simply deciding whether to believe an online rumor or not. It is a choice about the very nature of knowledge in the 21st century. It is a decision about who we trust to tell us the story of our universe and how that story should be told. To choose passive consumption is to accept that discovery is a process that happens behind closed doors, in sanitized laboratories and classified data centers, and that the public's role is simply to wait for the polished, approved press release. It is to accept the silence as a necessary part of a process we are not meant to understand. It is, in a way, to remain a child in the cosmic household, waiting for the adults in the room to explain what the strange noises from upstairs were all about. To choose active participation, however, is to declare that the tools of discovery no longer belong exclusively to the institutions. It is to assert that a network of dedicated, independent minds, connected by technology and united by a common purpose, can function as a powerful, parallel instrument of scientific inquiry. It is to say that we will not wait for the official narrative, but will instead endeavour to write the first draft of this history ourselves, with our own eyes and our own data. It is a declaration that in an age where a citizen can own a telescope more powerful than the one Galileo used to revolutionise our entire worldview, the responsibility to look, to question, and to share what we find falls upon all of us. This is the heart of the quiet crisis. It is not just a crisis about a strange object. It is a crisis of agency, a test of whether we are willing to take ownership of our own capacity for discovery. To truly understand why this choice is so critical right now, we must return to that deafening silence from the official channels and explore it more deeply. It is easy to leap to conspiratorial conclusions, to assume that a great truth is being deliberately and maliciously hidden from the public. But the reality is likely far more complex and in many ways far more unsettling. The silence is not necessarily the product of a single sinister decision. It is more likely the result of a confluence of powerful, deeply ingrained institutional forces, each with its own logic, each contributing a layer to the wall of quiet that now surrounds 3i Atlas. First, there is the simple, crushing weight of scientific conservatism. Science, as a discipline, is built upon a foundation of skepticism. The burden of proof for any claim is high, but for an extraordinary claim, it is, as Carl Sagan famously said, extraordinarily high. An institution like NASA or the ESA has its scientific credibility as its most valuable asset. That credibility is built over decades of meticulous, careful, peer-reviewed research. They cannot and will not engage publicly with unverified images circulating on Reddit. They will not comment on anomalies until they have exhausted every conceivable natural explanation, a process that can take months or even years of painstaking work. To do so would be to risk their reputation on incomplete data. From their perspective, the responsible scientific thing to do is to say nothing, to continue gathering data, and to wait until they have an answer that can withstand the harshest scrutiny of the global scientific community. This is not a conspiracy. It is the scientific method in action. But when the object of study is about to disappear forever, that slow, methodical process can feel like a form of paralysis. The institution's need for certainty is in direct conflict with the public's need for information about a transient, fleeting event. Second, we must consider the historical precedent for this kind of silence. As far back as 1960, the United States government commissioned a report from the Brookings Institution, titled Proposed Studies on the Implications of Peaceful Space Activities for Human Affairs. One small but now famous section of that report considered the potential consequences of discovering evidence of extraterrestrial life. The authors speculated that such a discovery could have profoundly disruptive effects on societies around the world. It could lead to the collapse of religious institutions, the disintegration of social structures, and widespread psychological instability. They even suggested that under certain circumstances, it might be prudent to withhold the information from the public, at least temporarily, to allow leaders time to prepare for the potential fallout. Now, this was a speculative report from over 6 decades ago, but it reveals that the idea of managing or even suppressing information of this magnitude for reasons of social stability has been a part of official thinking for a very long time. If the institutions observing Three-Eye Atlas are seeing something that even hints at non-natural origins, they are not just dealing with a scientific problem. They are dealing with a potential social and political crisis of unprecedented scale, and the playbook for that crisis, as suggested by their own historical documents, might very well begin with the word silence. Finally, there are the undeniable national security implications. Imagine for a moment that Three-Eye Atlas is confirmed to be an artifact of non-natural technology. Even if it is ancient, derelict, and inert, the simple confirmation of its existence would trigger a global race to understand it. What is it made of? What principles of physics does it operate on? Could its materials, its design, or its energy source be reverse engineered? The nation or entity that could first acquire and analyze even a small fragment of such an object would gain a technological advantage so immense that it would reshape the balance of global power overnight. In that context, the data streaming from our observatories is not just scientific information. It is potentially the most valuable strategic intelligence in human history. Is it any wonder, then, that this data might be treated with the utmost secrecy? The silence may not be directed at us, the public, at all. It may be the sound of powerful nations shielding their findings from their geopolitical rivals, moving the investigation out of the open forum of academic science and into the closed, classified world of defense and intelligence. When you layer these three forces together, the slow, cautious nature of scientific institutions, the historical precedent for managing socially disruptive information, and the immense national security stakes, the silence begins to make a terrifying kind of sense. It is the sound of a system under a stress it was never designed to handle, a system that is defaulting to its most basic, conservative, and secretive instincts in the face of a truly unprecedented unknown. And it is precisely because of this institutional gridlock that the role of the independent citizen observer becomes not just important, but absolutely essential. The official channels are quiet, but the sky is not. For those of you who are now feeling that pull, that deep nagging urge to contribute, let's move beyond the philosophical and into the intensely practical. What does it actually mean to look up and gather credible data on an object like this? It is a process that is both an art and a science, demanding patience, precision, and a healthy dose of self-skepticism. The challenge begins with simply finding the object. It is a moving target against a backdrop of moving stars, and its position in the pre-dawn sky will shift slightly each day. You will need up-to-date orbital data, which can be programmed into the controller of any modern telescope mount to ensure you are pointing at the right spot. Once you have it in your eyepiece, the real work begins. Capturing a scientifically valuable image is not a simple point-and-shoot operation. You're trying to photograph an incredibly faint object from the bottom of a turbulent ocean of air, our atmosphere. This atmospheric distortion, what astronomers call seeing, causes the image to shimmer and blur, obscuring fine details. To overcome this, you must take not one, but hundreds, or even thousands of individual long-exposure images. Each exposure, lasting anywhere from 30 seconds to several minutes, captures a fleeting moment of clarity. Later, you will use specialized software to analyze all of these individual frames, throwing out the blurry ones and keeping only the sharpest. The software then stacks these good frames on top of each other, aligning them perfectly. This process has a magical effect. The random noise from the camera and the atmosphere begins to cancel itself out, while the faint, consistent signal from the object itself gets amplified. It is through this painstaking process of stacking that a fuzzy, indistinct blob can be slowly coaxed into a detailed, high-resolution image. But how do you ensure that the details you're seeing are real, and not just tricks of the light or flaws in your own equipment? This is where rigorous methodology becomes your greatest ally. One of the most common problems is mistaking an artifact on your camera's sensor, a stuck pixel, or a tiny speck of dust, for a feature on the object you're photographing. A simple but powerful technique to rule this out is to physically rotate your camera by 90 degrees halfway through your imaging session. If the strange spot you're seeing is a sensor artifact, it will appear in a different position relative to the object in the second half of your images. If the feature is real, it will remain in the same place on the object itself, regardless of your camera's orientation. This simple act can definitively separate instrumental errors from genuine observations. Another critical step is to share your raw, unprocessed data files, not just your final, beautifully enhanced image. In astronomy, these raw files are typically in a format called FITS, Flexible Image Transport System. A FITS file contains not just the image data, but a wealth of metadata: the exact time of the exposure, the telescope's coordinates, the camera's temperature, and much more. By sharing these raw files, you allow other independent researchers to run your data through their own processing workflows. If 10 different people, using 10 different software packages and 10 different techniques, all process your raw data and all find the same anomalous feature, the credibility of that feature increases exponentially. This is the very essence of peer review, adapted for the fast-paced, decentralized world of crowdsourced science. We could imagine a global open-source repository where observers from every continent upload their raw FITS files of 3i Atlas each night, creating a living, breathing archive of data that would be the envy of any professional institution. This entire endeavor leads us to a much larger philosophical question about our place in the cosmos, a question that has haunted scientists and thinkers for decades. It is the concept of the Great Filter. The theory, in its simplest form, suggests that while the universe may be teeming with planets where simple life can begin, there is some kind of massive, improbable barrier, a filter, that prevents most of that life from ever developing into a spacefaring technological civilization like our own. The silence we perceive in the cosmos, the fact that the galaxy does not seem to be filled with the chatter of intelligent civilizations, suggest that this filter is very real and very effective. There are two terrifying possibilities regarding this filter. The first is that the filter is behind us. Perhaps the leap from non-living chemistry to life, or the leap from single-celled organisms to complex intelligent beings, is so fantastically improbable that we are one of the very few, or perhaps even the first, civilization in our galaxy to have made it through. This would make us precious, unique, and profoundly alone. The second possibility is far more chilling. The filter is still ahead of us. Perhaps every technological civilization, upon reaching a certain point, inevitably discovers a technology that leads to its own self-destruction, or triggers some kind of natural cataclysm. In this scenario, the silence of the galaxy is a graveyard, filled with the ghosts of civilizations that reached our level of development, and then, for some reason, went silent. Now, consider 3i Atlas in this context. If it is proven to be a technological artifact, what does it represent? Is it a derelict probe from a civilization that successfully passed through the Great Filter and is now exploring the galaxy? If so, its presence would be the most hopeful sign in human history, a message that survival and expansion are possible. Or is it a piece of cosmic debris, a silent tombstone from a civilization that failed to pass the filter? Is it a warning, a fragment from a world that destroyed itself, now drifting through our system as a grim omen of a fate that could await us? The object in our sky is not just a scientific curiosity. It is a potential data point in the single most important equation humanity has ever contemplated, the equation of its own survival. Its nature, whether natural or artificial, could tell us something profound about our own future. This is why the act of looking up, of gathering this data, transcends a simple hobby. It is an act of profound existential importance. The potential discovery of a non-natural object would instantly cure our species of its cosmic loneliness. For our entire existence, we have been the sole known audience for the universe's grandeur. To learn that there has been another, that we have shared the stage of existence with other minds, would be a psychological transformation on the scale of the Copernican revolution. It would force us to see ourselves not as the sole, central protagonists of the cosmic story, but as one small part of a much larger and much older narrative. It would be a humbling and ultimately unifying experience for a species so often divided by its petty terrestrial squabbles. The knowledge that we're not alone would change everything about what it means to be human. And so we circle back to where we began, to this quiet crisis unfolding in the margins of our awareness. The crisis is not just about the unexplained behavior of a single interstellar object. It is a crisis of information, a conflict between the slow, cautious pace of institutional science and the urgent, fleeting nature of a historic opportunity. It is a crisis of trust, forcing us to question whether the silence from official sources is a sign of responsible caution or a symptom of a system that is unprepared and perhaps unwilling to share a potentially world-altering truth. And it is a crisis of participation, challenging each of us to decide whether we will be spectators or participants in what could be the greatest discovery of all time. The final chapter of this story has not yet been written. Its pages are being filled in night after night in the cold, pre-dawn hours by a distributed network of human eyes and silicon sensors, all pointed towards a single, enigmatic visitor from the stars. Whether that chapter concludes with a mundane explanation that neatly resolves all the anomalies, or whether it ends with a question mark so large it reshapes our entire understanding of the universe, depends entirely on what we do now in this brief closing window. Think of it this way. Future generations may look back at this specific moment in time, at this November and December of 2025, as a pivotal point in human history. They will know the answer to the mystery of Three-Eye Atlas. They will read about the documented anomalies, the leaked photographs, and the institutional silence. And then they will ask a simple question. What did the people who were alive at that moment do? Did they recognize the significance of the opportunity they were given? Did they rise to the challenge, point their instruments to the sky, and demand answers from the cosmos itself? Or did they allow the silence to win, letting the opportunity fade away, forever unresolved, back into the infinite night? We are those people. That question is for us. The sky is waiting. We are those people. That question is for us. The sky is waiting. The institutions of humanity may have fallen quiet, but the universe itself is not silent. It speaks in a language of photons and physics, of spectral lines and subtle shifts in brightness. It is a message broadcast across millions of kilometers, not waiting for official permission to be heard, but simply for a receiver to be pointed in the right direction. Your telescope can be that receiver. Your patient observation can be the act of listening. The truth of Three-Eye Atlas is not a secret locked away in a vault. It is a signal waiting to be decoded.